With ideal gases, pressure, volume, temperature, and number of moles of the gas are all linked. But before we look at the ideal gas equation, we need to understand these relationships. And before we understand these relationships, we need to download our free PDF so we can be making our notes as we watch along. Link in the description. So this is what we're going to be covering today. So our first relationship is between pressure and volume, and this is called Boyle's law, named after the man himself. So as we can see from the graph, and yeah, this is always at a fixed temperature, the volume of a fixed mass of an ideal gas is inversely proportional to its pressure. So if you're not that happy with maths or up to date with your maths, so this is what an inversely proportional relationship looks like. So basically what we're getting here, so if we double the pressure, then the volume is halved. So let's say we have pressure here, pressure 1, pressure 2, although this is not exactly right, but yeah, so we are doubling the pressure. We can see the volume is going down by quite a bit. And yeah, so if we keep the same number of gas molecules, we can see that yeah, in our smaller box, the pressure has to increase because there's more particles hitting the container, so that's why we're getting an increase in pressure. So we can write this out as an equation. So yeah, so the pressure is directly proportional to 1 over volume, or pressure is directly proportional to a constant divided by volume. We can rearrange this to yeah, pressure times volume equals a constant K. And we'll find out in the next video that K is the gas constant, but for now we can just assume that it is a constant K. So this is really, really, really important. Okay, so now on to the next relationship, and this is Charles's law. So this is when the volume of a fixed mass of an ideal gas at a constant pressure is directly proportional to its Kelvin temperature. So that's the key thing, is that it's its Kelvin temperature. So yeah, so as you increase the temperature, you give the molecules more kinetic energy and their volume increases. So this idea was used to give us the concept of absolute zero. So if we look at this graph here, to give us the concept of absolute zero. So this is on the Celsius temperature scale. So you can plot data here, then you can kind of keep this line going all the way down until you get to this value here. So this concept of absolute zero. So, however, yeah, no real gas is an ideal gas at very low temperatures, as we found out in the last video. But you can keep plotting this line until you cross the x-axis, and then yeah, this is where this number is coming from. So there we go, exciting stuff. Okay, so now on to our next relationship, and that is for a fixed mass and a constant volume, the pressure is directly proportional to its absolute temperature. So yeah, our absolute temperature, we've got our pressure, and yeah, they are directly proportional to each other. So yeah, so this makes sense, as you heat the particles up, they have more kinetic energy, so moving faster, which results in them hitting their container harder and more frequently, which is a measure of what pressure is. So in our cold box, our particles would be moving slower, and then hitting the container with not as much force. Then in the hot box, so we've got the same number of particles, they're going to be hitting the container much harder and more frequently, and that's why we've got an increase in pressure. Okay, on to our final relationship, and this you won't find in textbooks, I don't think, but I have seen it on some exam papers. So this is the relationship between moles and temperature. So again, this is if the pressure and volume are kept constant. And then this is another inversely proportional relationship. And yeah, once we've spent a bit of time thinking about it, hopefully it makes some sense. So yeah, so because pressure and volume have to stay the same, either the number of moles or your temperature has to change to make sure that the pressure and volume is constant. So if we have a look at a colder line, so a colder temperature, a colder line, we're going to have a lot more particles. In this case, we've got the same volume to kind of keep the pressure the same. If we compare this to a hotter temperature, we need to have much less particles to give us the same pressure, in this case, and the same volume. So there we go. So those are the 4 relationships that lead to the ideal gas equation. And then being able to understand and draw these graphs is very important, as they always crop up in exams one way or another. And then make sure you stick around and watch my next video, which is going to be on the ideal gas equation. And remember, if you're liking the content that I'm putting out, it will mean so much to me if you like and subscribe. And then I'll keep making chemistry videos just for you. All right, catch you in the next one. Ciao, ciao.